Okay, so in this lesson, we're going to learn how to solve an equation in which some of the terms of the equation have denominators that are numbers other than the number 1. So in an equation like the ones we've been solving so far, we'll have something like y plus 1 equals 4. And in this equation, every single term technically has a denominator that's a 1. You could write it as y over 1 plus 1 over 1 equals 4 over 1. But in the equations like the ones I'm about to do, they have denominators that are other numbers. So in this example, you can see we have y over 2 plus 1 over 4 equals y over 6. And in order to solve for this problem, we're going to have to find a common denominator. The goal is just to get rid of that denominator because it's kind of in our way and it's kind of making this problem more complicated than it needs to be. So we're going to get rid of that denominator by multiplying the numerators of every term by the least common multiple. So in this equation, the least common multiple of the denominators is 12. That is the smallest possible multiple that I can get to using 2, 4, and 6. So I'm going to multiply every single term by 12. So once I multiply all those numerators by 12, I'm going to end up with 12y over 2 plus 12 over 4 equals 12y over 6. And now this is going to help me get rid of all those denominators. So I'm going to simplify all of these terms and I will end up getting rid of those denominators. So this first one becomes 6y. The second term becomes 3. And that third term becomes 2y. And now I've set this up to be a completely linear equation with no denominators in my way, and I can just solve this like a regular problem. So I need to get all those y's to the same side. So I'm going to subtract the 6y and put it on the other side. So I end up with 3 equals negative 4y. Then I'm going to divide by that negative 4. So I get y equals negative 3/4. And that is my final answer. Okay, so for this one, I need to try to find the least common multiple of 7, 2, and 3. So let me just work through that really quick so that you see how I would do this. So my multiples of 7 would be 7, 14, 21, 28, 35, 42, 49. That's as far as I'm going to go. So I could go and write all the multiples of 2, but I need to find one that's both a multiple of 7 and a multiple of 2. And I know that anything that's a multiple of 2 is an even number. So let me go through these multiples of 7 and only underline the even numbers. So I've got 14, 28, and 42. And then let's see if any of those that I underlined are also multiples of 3. So 14 is not, 28 is not, but 42 is. And a way to know if it's a multiple of 3, I can just add up those numbers. So 4 plus 2 is 6, and 6 is a multiple of 3. So I know that 42 is a multiple of 3, and 3 times 14 is 42. So 42 would be my least common multiple. So I'm going to multiply every single one of these terms by 42. And a simplified way of doing this, instead of actually multiplying it and then simplifying every fraction, I can just do 42 divided by 7 and put that in the numerator. So 42 divided by 7 is 6, and I'll multiply that by 2, so I get 12x minus 42 divided by 2, which is 21, times this 3 here is 63x equals 42 divided by 3, which is 14, so that'll be just a 14. And now I can just go left to right and solve for the x here. So 12 minus 63 is negative 51x equals 14. Now I just divide by that negative 51. And that's kind of ugly, but that actually is the simplified answer. So x equals 14 over negative 51, or negative 14 over 51, and that's my final answer. Okay, let's look at this one. So when I first look at this problem, it doesn't look like every single term has a denominator, but I'm just going to give 3 a denominator, and I'll put that over 1. So I need to find the least common multiple of 2, 7, and 1. So this is an easy one. I'm just going to multiply all of those numbers together and just find the least common multiple of 14. So I'm going to have to multiply all of those numerators by 14. And when I do that, this middle term here is going to set me up for some distributive property. So I have to make sure that I do that one right. So when I simplify this fraction here, the 14 over 2, I really end up having a 7 on the top times that 3y, which is 21y. Over here, I have 14 over 7, which simplifies to a 2. So I can get rid of that denominator and really just multiply the top by 2. And when I distribute that 2, I have to do the 2 times the 8 to get 16, and the 2 times negative 4y, which is a negative 8y, equals 14 divided by 1 is already simplified, so I'm just going to do 3 times 14, and I will get 42. And now I'll just go left to right to solve for that y. So let me combine these like terms here. I have a 21y minus 8y, which is 13y. And I want to get rid of that 16 that's on the left here. So let me subtract that and put that one over here. So I end up with 13y equals 42 minus 16, which is 26. Now I just have to divide by that 13 on both sides, and I get y equals 2. Okay, so this is the last one. Let me just enclose those binomials in parentheses first so that I don't forget to do any kind of distributive property. So I got to make sure that those terms stick together. And let's find our least common multiple of 4, 2, and 10. So I'm going to start by writing out the multiples of 4. So I've got 8, 12, 16, 20. And let me underline all the ones that are multiples of 2 as well. That would be all of them. They're all even. And now the first one that is also a multiple of 10 would be this 20 here. So I know that my least common multiple is 20. So I'm going to have to multiply all of these numerators by 20. Okay. And then I'm going to simplify this outer fraction that happens here. So the 20 and the 4, 20 over 4 is 5. So I can really just multiply that by 5 and get rid of that denominator. And in this one, I have a 20 divided by 2, which is just 10. So I'll make that a 10. And in this last one, I have a 20 and a 10, which simplifies to 2 when I divide that out. And now I'm just going to go left to right and do my distributive property. So here I have a 5 times x, which is 5x, and a 5 times 1, which is plus 5. Over here I have negative 10 times 3, which is negative 30, equals, another distributive property here, 2 times 2x is 4x, and 2 times negative 9 is negative 18. Now I'm just going to combine those like terms, go left to right. So I've got some like terms here. 5 minus 30 would be negative 25. And I can't lose that 5x over here. So I have 5x minus 25 equals 4x minus 18. And I got to get those x's together. So I'm going to subtract the x that's on the right and subtract it on the left as well so that I get that over to the left. So 5x minus 4x is just 1x or x. And I also want to put that constant on the right, the one without a variable. So I'm going to add it from the left side to the right side. And negative 18 plus 25 is 7. So I end up with x equals 7.